mass positioning apparatus for seismic sensor features a pivotable boom with a divisional point, incorporating adjustment mechanism and an actuator for precise positioning, along with a position determination system to ensure stability and accuracy in measurements. While broadband seismometers often rely on adjustable mesh system, either motorized or manual, to maintain an inertial mass at this null point, they face challenges such as jamming and lack of feedback on position, complicating diagnostic without desampling. Therefore, there is a demand for more reliable and economical mass positioning systems that provide a real-time position and diagnostic data, fitting within a 16 sensors enclosures to support future adjustment. The system features an axis mechanism that includes a mass positioning system for the seismic sensor, which consists of an inertial mass called the boom, connected to a frame via a suspension, allowing to the boom to act like a pendulum with minimal mechanical friction. The capacitive displacement sensors comprise two metal plates fixed to the boom and one center plate, fixed to the frame, detecting the boom's position relative to the null point, where the center plate is equidistanced from both or plates. A metal spring supports the boom against gravity and provides a restoring force to return it to the null point, attached at one end to the boom and suspended at the other end by a wire. The mass positioning system includes components like tensioner arm, a flexible hinge, an actuator, and a stepper motor to always position the inertial mass on the boom at the 0 point. This diagram provides a detailed rear view of the axis mechanism of the seismic sensor. Focusing on the mass positioning system, the end of the wire is attached to the tensioner arm, which is secured to the frame via a flexible hinge. The actuator includes a drive screw and rotates the tensioner arm to adjust the boom's positioning by altering the angle of the arm. A stepper motor connected to a reduction gearbox and an external gear precisely controls the movement of the drive screw. Ensuring the boom remains at the specified 0 point, the system enables automatic adjustment of the mass position to maintain the seismic sensor's accuracy in response to environmental changes like temperature or slope. The tilt can be calculated in degrees based on the geometry of the axis mechanics. Alternative embodiments of the invention includes devices that report the position of the mass apparatus relative to its operational range in two ways, by using a linear position transducer attached at one end to the tensioner arm, and at the other end to a fixed point of the frame, providing an analog or digital output signal proportional to distance measured by a microprocessor. By employing a rotary position transducer that is integral to our gauge with any of the rotating components such as the motor, reduction gearbox, gear driver, actuator, or similar components. Just for information, overview of processing module. The block diagram illustrates the structure of processing module 1, which integrates various submodules to manage and control the system effectively. Interpreting module 2 processes data received from other modules. This module includes a programmable microprocessor. Position determining module determines the current position of the system, provide essential input to the interpreting module for further analysis. Null point measuring module 4 measures and establishes the null point of the boom, ensures the system can return to precise starting position. Upper and lower limit detector module detects the maximum and minimum movement limits of the system, prevents damage by stopping movement when limits are reached. Output module 6 output parameters such as position to the user, provides an interface for users to view relevant system status information. Motor control module control the electric motor to adjust the mechanism, receive instruction from the interpreting module to operate the motor as needed. For the summary, The mass positioning apparatus for seismic sensor features a pivotable boom with a defined no point and include adjustment mechanism for precise positioning, an actuator for accurate movement, and a position determination system to monitor adjustment within its operational range. This design ensures stability and accuracy in seismic measurements by maintaining the optimal alignment of the mass. Modifying the mass location of boom spring can change its tension by altering the axis mechanical tilt, adjusting the center of mass, or shifting the no point, while the advantage of position detecting methods using various devices for mass positioning are similar to those of existing inventions. The explanation and illustration should not limit their application. That's all from our presentation. Thank you very much.